So we're going to be using your knowledge of vector addition and multiplication in a slightly different way. It'll feel almost reversed from what we were doing previously. So let's just jump in and I can show you because it's a little hard to explain what we're doing. So here I have a shape. We're going to do this with a bunch of shapes, but we're going to do this with a rectangle to start off with. And I've labelled two of the sides as vectors. So this is vector u and this is vector v. Now, we should be able to express a bunch of different lines on this shape and lines that we'll create on this shape using just the vectors u and v. Okay, so let's start with a simple one. So this is new notation. This says, what is the vector joining point D to point C? Okay, so what is this vector here? Okay, let's draw it in. Okay. And you might say, it's not labelled. How am I supposed to know what vector DC is? But remember, vectors have direction and they have magnitude. They don't have position. You can move them around. So this is vector u, and it is the same length, and it is moving in the same direction as this vector right here. So vector DC is actually equal to this vector right here, which is vector u. Easy, straightforward. Next question. What about vector CD? Okay, well, what's vector CD? Vector CD is from here to here. It's going in the other direction. All right, so we'll get rid of that. It's going downwards. Okay, same length, same direction as u, but flipped 180. So vector CD is not vector u, it's vector negative u. Vector go up, vector go down. Okay, we can do the same thing if we want to with vector BC, right? Because AD is equal to V. So vector BC would also be equal to V, same direction. Vector CB, flip it around, it's not V anymore, it's negative V. All right, we're just warming up. What about vector AC? Okay. Well, vector AC is this vector here. From point A to point C, it's this vector here, arrow moving in that direction. And you might say to yourself, how? How do we do that? Well, we use a combination of vectors. We add some vectors together. So where do we want to start? We want to start at A, right? And how could I get from here to here using the vectors I know? Well, I could travel along this vector, which is V, and then I could turn and travel along this vector. Now, that vector is the same as that vector in that direction, so U. If I go V plus U, that's equal to V plus U. V plus U, we know that that's U, is equal to V plus U. Done. Easy. So straightforward. We're just doing the addition, but we're sort of spotting it in the picture and creating it for ourselves. Now, you might have seen it a different way. You might have thought, well, if I want to get from A to C, I should travel upwards first. I should travel along U first. And then I should travel from B to C, and this vector is vector V, so U plus V. V plus U, U plus V, same thing. So whichever way we went, we would get the same answer. Neat. Okay, another one. This one is, obviously we're going to try to make things a little trickier as time goes on. Let's go BD. Okay, so from point B to point D is there. Okay, how do I get there? Think about it. Okay, one way to get there would be to go straight down, so along this vector, but vector U is pointing up, so along that way is down. So negative U, that's negative U if we go downwards, and then across, so that's positive V. Okay, there's a good answer. You could have done it a different way. You could have said to get from B to D, I'll go along V first, and then I'll go down this one, which is negative U. Two paths, negative U plus V is the same as positive V minus U, so they're the same. You might think I'm finished here, but we can add just one more small complication to the mix. So I've added in some midpoints. E is the midpoint between B and C, and F is the midpoint between C and D. Okay, so we can use these linear combinations not just for whole numbers, but for halves as well. So, or for thirds, or for quarters, or whatever we need to do. So if we wanted to go from A to E, so vector AE, now vector AE looks like that, right? How do we get there? Well, we could travel up U, and then traveling from B to E, it's not all the way along V, is it? This is V, but it's halfway along V. So it's equal to up by U and then plus half of V. So our answer, vector AE, is equal to vector U plus half of vector V. And you might think, well, you did other ways. You went other ways in the other questions. Could you go a different way? Yeah, you could. It's going to be less efficient, but of course you could. Vector V plus vector U. I need my squiggles. I need to remember your squiggles. I should be doing squiggles, 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 squiggles. Okay. Vector V plus the vector U, and then this vector here, which is half of negative V. So minus half V, because that's negative V, right? What's V plus U minus half of V? Well, the U is just U. 1V minus half of a V would be half of a V. And you can see whether I went the short way, U plus half of V, or whether I went the long way, V plus U minus half of V, this vector is still U plus half of V. This vector is U plus half of V. That's the definition of it. Just as sure as 2 plus 2 equals 4, this is equal to U plus half of V. And of course, very, very quickly, I'll do E to F. E to F is, I can go from here to there. So that's half of V across. And go from here down to here. U is in that direction. We're going halfway and we're going in the opposite direction. So minus half V. And if you want to, you can express it factorized. Half, oh, that's U, sorry. So half of V minus U. And that is this vector right here. Okay, so it starts off very, very simple, but then it starts to get more and more and more complicated. So take your time with it. We're drawing everything with arrows and adding these arrows together and expressing different relationships using these arrows.